Okay, welcome back. We are doing 5.2, number 5, ready, set, go. And this is a word problem, and we're reviewing how to do this as we review for our test. So this one says um, a theater, I don't know why I read that right now as a Heather. A theater wants to take in at least $2,000 for the matinee. Children's tickets cost $5 each, and adult tickets cost $10. The theater can seat up to 350 people. Find five combinations of children and adult tickets that will make the $2,000 goal and not be more than 350 people. So we're at the point, because we've already finished this chapter, that we can actually solve this um, system, right? So let's do what they asked us to do first and just find sets of numbers that work. And while you're doing that, you could also be a boss and start figuring out what our equations would actually be. Okay, so I'm going to read it again. So whenever I do word problems, if you understand how to solve it after the first read through, you are amazing. I need to learn from you. I usually have to read through the problem at least 2 times just to, number one, understand the problem and then go back and grab details. Okay, so I understand so far that there's a theater. They're trying to they want to make this much money. Children's tickets cost this much money. Adult tickets cost this much money, but the theater only holds this many people. So there's all of these kind of constraints, and we want to make sure that we're meeting all of those things. Because certainly you'd be like, oh, one combination of people that would work would be 1,000 children and 1,000 adults to make $2,000. But that doesn't work because the theater can only hold 350 people, right? So let's see. What would you do? How would you figure? Like, give me a combination of that would actually work here. Oh, you're giving me like a system. I like it. Okay. So what would it like? How many? Give me a number for children that would work. Oh, you guys want to solve? You guys want to just write this equation, the system, right? Okay. So yeah, I agree. This is probably going to be a system of inequalities, right? So a theater wants to take in at least $2,000. So when I start doing this, I organize my information by what they gave me. So I notice that they're giving me money information. So there's like something with $2,000, right? And then this is like almost like the total that they want. And then it says children's tickets cost $5. So then that means I need a children's, and then this is $5 per ticket. And then it says adult tickets cost $10. So this is adult. And this is $10 per ticket. And then the theater can hold up to 350 people. So then here I'm going to put people. And the total number of people I can is 350 max. Okay. That means I can't go over. And then they said they want to make at least $2,000. I don't know how many children there are, so I'm going to write C. I don't know how many adults there are, so I'm going to write the variable A. And then I'm going to start writing my equations. So one of my equations I'm going to put as C plus A. And then I'm going to put 350. And then can I have more than 350 or less than 350? Can I have more than 350 and less than 350?
More. It says at least.
Wait. For people.
Oh, no. You can only have 350 people.
Yes. So this has to be it has to be like less than or equal to. Does that make sense? And then I'm going to go $2,000. And then think about 2,000. Do I want to make more than 2,000 or less than 2,000? I want to make more. Very good. So
More.
yeah, more. Okay. So then I have to figure out how to include that $5. So certainly some people are going to write this and they're going to go 5 plus 10, which makes no sense because 5 plus 10 is 15, which is not greater than 2000. So 5 represents how much it costs per child's ticket. So if I say I want like 100 children, how much money would that be and what operation did you use? And so you guys would say, oh, Ms. Johnson, you're multiplying. So this would be 5C plus 10A. So here's my two inequalities, which if you haven't gone through this whole chapter, writing these inequalities actually doesn't make sense yet. So we're at the end of the chapter and we're reviewing. So this actually makes sense. So now they want some combinations. So the easiest way for me to come up with combinations is by graphing. So I'm going to graph these two. And it says, I'm going to use X for C just because it's in that order. So X plus Y has to be less than or equal to 350. And my next one is 5X plus 10Y has to be greater than or equal to 2000, right? And then so I'm going to kind of like put this away and look at my, oops, where's my, there it is. Okay, there goes my, there it is. Yay, me. Okay. So again, we talked about this. The solution set is the shaded section that's shaded twice. Okay, so anybody in this like only red section, that's not a solution to the system. That's only a solution to one of them. It has to be shaded in this doubly shaded section. So can you give me some combinations of people? Okay, let's see. Some of you have already done some. Someone said 150, 150. Let's see. 150 looks like there, and 150 looks like there. Looks like it's like right here. So you can't see where I'm talking about because I can't point on this thing. But 150 is here, and then 150 would be here. Yeah, I agree. 150, 150 works. It's in that purpley section, doubly shaded. Someone else said 60 comma 240. 60 comma 240. Oh, you know what I could do? I can graph that point, and then that would make more sense. Okay, so let's check 60 comma 240. And do you see that green dot? Is he in the right section? Yeah. So that's a yes. So as long as you're choosing anybody on there, I'm going to be a little bit nitpicky. What about this guy? What about that intersection point? Is he a winner, winner, chicken dinner? Is he a winner, winner, chicken dinner? And the answer is, what do you think? Yes or no? Just guess right now. Who cares? You're not going to get it right. Yeah, very good. The answer is yes. Ms. Johnson, why is it a yes? Because both of those lines are solid. If one of those lines happen to be not solid, I'm changing the equation right now, okay? Since one of those is dashed now, it is not a solution. Our original equation actually had it equal to, so it is a yes. It's a yes. When they live on solid lines, they are part of the solution. Okay. Very, very good. Have a great day. Hope that made sense. Bye.